Welcome to the chapter 12, chi-square test of independence. Objectives of this lesson: explain the purpose of the test of independence and discuss the nature of the chi-square distribution. Test of independence means we are going to test whether is there any dependencies among variables. In this lesson we are going to discuss about using chi-square test. How do we test the dependencies among two qualitative variables, and here we are going to use the contingency table approach. That's why the second objective states that introduce the procedure contingency table approach of carrying out the chi-square test of independence. Then finally we hope to describe the calculation of the chi-square statistic and explain how to conclude on the test performed using the contingency table. At the end of this lesson, students should be able to identify whether the conditions are satisfied in a given situation in order to apply the chi-square test of independence. Prior to apply the chi-square test of independence, we have to check few conditions. Then the second outcome is that students should know how to apply the chi-square test of independence and how to conclude the results. Now first see how to define the test of the independence. It says that in some circumstance we want to determine the significance of difference in characteristic between two or more groups. That indicate we are going to test whether is there any dependencies or any relationship among two or more variables. In today's lesson we discuss how to identify the relationship between the two qualitative variables. Here we are going to use the chi-square test of independence. It is extremely flexible method of analysis that allows us to search for dependencies between different methods of classifications. This test is most often used as a test of independence. That means we just test the relationship among qualitative variables. That's why here indicate we use nominal or ordinal scale variables. We are going to test whether independencies or dependencies among the nominal or ordinal scale variables. Now to understand this scenario clearly, you can see one example about the test of the independence. As example, it may be used to investigate the relationship between opinion and gender. The two variables here are opinion and gender. In few slides we are going to discuss this example. In that example you can clearly understand how we investigate the relationship between opinion and gender. Another example is investigate the relationship between brand preference and social class. Two qualitative variable here is that brand preference and social class. Using the test of independence we can check is there any relationship between brand preference and social class. And the third example is investigate the relationship between education level. This is a ordinal scale variable, and the attitudes about an issue. This is also a qualitative nominal variable. Before move to the chi-square test of independence, just see some properties of chi-square distribution. Now you have idea about the normal distribution. Now see some properties of chi-square distribution. Normal distribution is a symmetrical distribution, but the chi-square distribution is a positively skewed distribution. if we say the random variable x follows a chi-square distribution, this indicates that the random variable varies. That means that random variable can have any positive value. The random variable varies from 0 to infinity. This is the infinity sign, very large number. Therefore, for chi-square distribution, this is a square distribution. Therefore, it contains positive values only. This distribution is positively skewed, and if degrees of freedom, we use df to represent the degrees of freedom. The degrees of freedom increases. Later we will discuss how to calculate the degrees of freedom for the chi-square distribution. This chi-square approaches as symmetric distribution. Even though it's a positively skewed distribution, this property says that if the degrees of freedom increases, it approaches to symmetric distribution. As for the normal distribution, chi-square distribution is also a family of distribution, each of which is characterized by a certain number of degrees of freedom, and there is a particular distribution for each degrees of freedom. You can clearly see the shape of the chi-square distribution, except the within brackets indicate the particular degrees of freedom. The red curve indicates the chi-square distribution with 1 degrees of freedom. This blue color one, chi-square distribution of degrees of freedom 5. This one, chi-square, the degrees of freedom equal 10, except the first one. That means the chi-square distribution with degrees of freedom 1. All other chi-square distribution start with the 0, and peak gets somewhere here, then approaches to 0. And also you can see the second property indicated in the previous slide. It indicates that if degrees of freedom is increasing, this skewed distribution approach to symmetrical distribution. When degrees of freedom equal 5, this is a blue color line distribution. It's a clearly you can see it's a positively skewed distribution. The second one, when degrees of freedom equal 10, relative to the first one, this is a symmetric. But when we increase up to 15, degrees of freedom equal 15, the red color distribution, we can say more close to the symmetrical distribution compared to the other two. Then see how we apply the chi-square test. The test is good for nominal or ordinal scale variables. That means we can investigate the relationship between nominal or ordinal scale variables, and this test satisfies two objectives. That means performing this chi-square test, we can check are two qualitative variables related. The two qualitative variables are related or dependent, or are there differences, significant differences among two or more population of qualitative variables. That means keep remember, using the chi-square test we are going to investigate the relationship between two qualitative variables. Therefore, hypothesis for the chi-square test, always we write H naught, the two variables are independent. There is no relationship between two qualitative variables. H1, the two variables are dependent. Then see the assumption for the chi-square test. Prior to apply the chi-square test, we need to test these conditions. Every observations falls into one and only one category. Earlier we say that we are going to use contingency table approach. That means we consider two qualitative variables, two-way table, then later we will discuss about few examples, then you can clearly understand the cell numbers. Then every observation falls into one and only one category, falls into categories, particular category of the first variable and the particular category of the second variable. All the observations are independent of one another. The third condition is the sample size n should be large. To confirm the large sample, we need to be consider the following condition. Then we have to check these conditions to confirm for the large sample. The df indicate the degrees of freedom. Degrees of freedom should be equal. If degrees of freedom equal 1, then n should be, that means number of observation in the sample should be greater than or equal 20, and E indicate the expected frequencies. Expected frequency should be greater than or equal for 5 in all cells. That means if the degrees of freedom equal 1, then these two conditions should be satisfied. N should be greater than or equal 20 and all expected frequencies should be greater than or equal 5. The second condition, second case, if degrees of freedom lies in between 1 and 30, that means degrees of freedom greater than 1 and less than 30, in between any value in between these two ends 1 and 30, then the expected values in all cells, not all cells, expected values in at least 80% of cells should be greater than or equal 5, and in the remaining cells expected value should be greater than or equal 2. Once when we discuss one example, you can clearly understand how to define the cells and expected frequencies, all that. Up to this point, just keep remember, if degrees of freedom equal 1, then the n should be greater than or equal 20, and expected values, E means expected frequency, should be equal or 5 in all cells. The second case, if degrees of freedom lies in between 1 and 30, then 80% of all cells expected frequency should be greater than or equal 5, and in the other cells expected frequency should be greater than or equal 2. If degrees of freedom is greater than 30, then all expected frequency should be greater than or equal 1. That means first we have to consider about the degrees of freedom. Later we will discuss how to calculate the degrees of freedom. Then based on this one, you have to check the other conditions. Now see how to define the contingency table. It contains rows, set of rows and columns. The rows indicate the categories of one variable. The columns of these vertical lines represent the categories of variable 1. In this example, the columns represent the categories of variable 1, rows indicate the categories of variable 2. Now here see, both variables consist 5 categories. Now suppose the first category consists 5 categories and the second variable also contains 5 categories. Now initially given the frequencies, those frequencies we call as observed frequencies. That's why we present the first cells as cell address 0, 1, 1. That means this number or this values belongs to first category of the first variable and first category of the second variable. First indicate the row number, then indicate the column number. Observed frequency belongs to first category of the second variable and first category of the first variable. In that way we can define the cell address for this one as 0O12, observed frequency O, not 0, O. 1 represent the first value, represent the category number of the variable 2, row number, then the column number. That means this values belongs to first category of the variable 2 and second category of the variable 1. Then you can say what is the cell address for this one. It should be O13. That means this values belongs to first category of the variable 2 and third category of the variable 1. In that way we can define O14. O indicate the observed frequencies, that means given frequencies in the example. O15 first belongs to first category of variable 2 and fifth category of variable 1. Then R1 represents the first row total. R1 the first row total, then add all these observed frequencies, O11 plus O12 plus O13 plus O14 plus O15. Then this cell address is O21, that means it is belong to second row and the first column. That means row numbers present the categories of one variable, columns represent the variables of the categories of the other variable. In that way we can present the cell addresses. O21, O31 means this is belongs to third category of the variable 2 and the first category of the variable 1. Column total represented by C, C1, C2, C3 likewise. And C represent the column totals, R represent the row totals, R1, R2, this number represent the particular row, and N represent the grand total, sum of the row total or sum of the column total. This sum of the column totals and sum of the row total should be equal, that is equal to N. Now see this example to get the idea about how to apply the chi-square test for independence. Now example 1 state that is there any significant difference between males and females about the opinion on nuclear disarmament. That means removal of nuclear weapons, like that. Now this is the given frequency table, that is we call as observed frequencies. Now just see the variables represent here, gender and opinion. Both are qualitative and both are nominal scale variables. Gender and opinion variables, both variables are in nominal scale. The gender consists two categories, male and female. These columns represent the categories of gender variable. Rows represent the categories of opinion. Two types of opinion, favor of nuclear disarmament, against about this statement. Then the first row total, just add 44 plus 32, 76. The second row total, number of against, 16 plus 28. This 44 represent the total number of peoples, 120. In that sample there are 120 peoples. The first 44 of them belongs to male and favor. 32 of them belongs to favor, that means they make a favor decision, and those 32 are female. 44 the favor, and those are male. 44. The 76 indicate out of this 120, 76 of them are favor. Likewise, right? The total male number 44 are favor, and 16 males are against nuclear disarmament. Then sum of these two produce the male number of males in that sample. Number of females 32 plus 28. This 60 and this 60 we call as a column totals. The row totals 76 and 44. The total number of observation, that is we call as a grand total, 120. Then you can write down by looking that observed frequencies table. We can write down the observed frequencies. or 1144, that means that is belongs to the first category of gender, that means male and favor. 44 female and favor, 32 12 012 021, this 16, that means 16 peoples belongs to against and male category. 022, that is equal 28. In the row totals 76 and 44, columns total 60 and 60. Then the based on before calculate the expected frequencies, first write down the null and alternative hypothesis. Always write H naught, formulate H naught as the two variables are independent. Then we can state that opinion is independent on the gender of the person. That means the opinion is not depend on the gender. Alternative hypothesis, null hypothesis H naught, opinion is independent on the gender. Always the null hypothesis for the chi-square test, the two variables are independent. The H1 alternative hypothesis, opinion depends on the gender of the person. The two variables are dependent. Then calculate the expected frequencies. Based on the observed frequencies, we have to calculate the expected frequencies. To calculate the expected values, we use this assumption: if two categorical variables are independent. Under that assumption, we can calculate the expected values. In general, we can say the expected values belongs to ith row and jth column. Ith category of first variable and jth category of second variable. I represent the first number, represent the row value. The second number represent the columns. Therefore, expected value belongs to ith row and jth column is equal ith row total Ri, jth column total Cj divided by total number of observation. This is a general formula. Here you can see R represent the row total, Ri represent ith row total, Cj jth column total, N grand total, sample size. Now here see how do you calculate the degrees of freedom. R represent the categories of the one variable, C represent, that means number of rows. R represent number of rows, C represent number of columns. Number of rows means the categories of one variable. Number of columns means categories of the second variable. In our example, both variables contains two categories, therefore R equal to C equal to. Therefore, degrees of freedom for that example, 2 minus 1 into 2 minus 1. 2 minus 1 equal 1, 1 into 1. The degrees of freedom for that example equal 1. Then see, for example, how do you calculate the expected frequencies for the cell number 1. That means expected frequencies belongs to the first category of the one variable, gender variable, and opinion variable, and first category of the gender variable. Then we have to take the product of first row total into first column total. Using these two numbers you can get R number and C number. R1 and C1 divided by n. Here if you have I, then you have to here write Ri, here Cj, then here 1 R1 into C1 divided by n. As a step number 2, the first step number 1 just state the hypothesis. Then in the step number 2, calculate the expected frequencies. Now when you calculate the expected frequencies, you have to satisfy these conditions. That means row total and column total should be remains as given in the observed frequency table. Then you have to calculate E11, E12, E21, E22. E represent expected frequencies table. Then see how do you calculate E11. This is the general formula. Eij Ri, that means first value number indicate the row number, the second value j represent the column number. Then E11, first row total into first column total divided by n. Here first row total is 76, first column total 60, grand total 120, that means total number of observation or people 120. Then the answer equal 38. Then E11 equal 38. The same way you can calculate the E12. Then just find the row total of the first row, that means the first row number 76. Then find the corresponding column total, that means E12 belongs to the first row and second column. Therefore you need to get the first row total and second column total. 76 into 60 divided by 120, that is also equal 38. That means the column total, both column totals is same, equal. Therefore these expected values does not make differences, the same values you can get 38 and 38. E21, that means this is belongs to the second row and first column. Then take the second row total, product of second row total and first column total, 44 into 60 divided by 120. This is equal 22. E22, then we have to take the, now see the first number 2, then get the second row total and second column total. Second row total 44, second column 60 divided by 120, same values, then answer equal 22. In that way you can calculate the expected frequencies, and also you can determine the degrees of freedom. For this example, 2 minus 1 into 2 minus 1, degrees of freedom equal 1. Then before apply the chi-square test, once you calculate the expected frequencies, just check whether the condition is satisfied or not. When we go back to the condition, the large sample, now in our example degrees of freedom equal 1, then n should be greater than or equal 20. In our example n equal 120, therefore first condition is satisfied, and check whether the all expected values is greater than or equal 5. Yes, all expected values greater than 5 because the E11, E12 38, E21 and E22 22. Therefore all expected frequencies are greater than 5. Therefore condition is satisfied. Then we can apply the chi-square test for independence, and as a third step then we need to calculate the test statistics. In here test statistics defined as we have to taken sum over this calculation. That means first we need to subtract expected frequencies of particular cell from the corresponding observed frequency. Then we have to square this difference, and that value we need to divide by corresponding expected frequency. We need to take the summation over all the cells. Once you do the example, you can see the clearly understand the process. In simple way we can define the chi-square calculator. That means test statistics follows the chi-square distribution. Now again see the observed frequencies 44, 32, 16, 28. Expected frequencies 38, 38, 22 and 22. Then let's take the difference between observed frequency and expected frequency of particular cell. Then O11 minus E11, then square this difference, then divide it by corresponding E value, expected frequency. Here 44 minus 38, then just square this difference, divide it by 38, and we have to get the summation over all the cells, plus then consider the O12 and E12, the corresponding expected frequency of observed frequency. Here observed frequency is 32, corresponding expected frequency is 38. Then 32 minus 38, just square this difference. This square, when we square this one, it produces a positive value. Then divide that result by corresponding expected frequency, that is equal 38, plus then consider the next paired observation O21 and E21. 16 minus 22, square this difference, then divide it by 22. 28 minus 22, square this one, then divide it by 22. First square the value, then divide that squared value from the corresponding expected frequency. Then here 44 minus 38 is equal 6. 6 to the power 2, 36, divide by 38. 32 minus 38, minus 38, again minus 6, minus 6 to the power 2, 36 over 38. 16 minus 22, 6 to the power 2, 36 over 22. 28 minus 22, again that is this difference equals 6. 6 to the power 2, 36 over 22. Then you can simplify these values. Then the final answer, chi-squared calculated value equal 5.166. And see the fourth step, then we need to determine the critical value. And this is the chi-square distribution. Then we need to find out the table value. Earlier we get the calculated value. That calculated value follows the chi-square distribution. Then we need to check the chi-square table value. The shaded area we call as a rejection region. This area we call as a non-rejection region. Then see how do you get the chi-square table. Chi-square degrees of freedom and we need to know about the degrees of freedom and significance level. In this example, the degrees of freedom equal 1. Then see how do you calculate the degrees of freedom. R minus 1 into C minus 1. That means that we have to subtract 1 from the categories of one variable, and also we need to subtract 1 from the categories of the second variable. Both categories consist 2 categories, and 2 minus 1 into 2 minus 1. Then 1 into 1 equal 1. Then here significance level equal 0.05. Then we need to find this value using the chi-square table that is also given in your course manual. At the end of, just after the normal table and t table, the chi-square table is given in your course manual. This chi-square table, then read that value here. Just indicate the degrees of freedom. In our example, degrees of freedom equal 1. The significance value 0.5. Then this value equal 3.841. Chi-square degrees of freedom 1, alpha equal 0.05. The table value equal 3.8414. To make a decision, we need to compare calculated chi-square value and table value. If the calculated value belongs to this shaded area, that means this critical point, this critical value is equal, that means this point equal 3.841. The decision criteria, if our calculated value belongs to this shaded area, rejection region, we reject H0. If the chi-square calculated value is less than this value 3.841, we do not reject H0. The step number 5, compare calculated test statistics with the critical value and make the conclusion. Then see the decision rule. If chi-square calculated value is greater than chi-square table, that means this value belongs to the shaded area, rejection region, then we reject H0. In this example, our calculated value is equal 5.166, table value equal 3.841, and this is the critical value, table value. Then this value is clearly, you can see this is greater than 3.841. That means this value belongs to this shaded side. And chi-square cal value 5.166 greater than 3.841. Then our decision reject H0. Then keep remember how do you formulate the H0. The two variables are independent. Therefore, conclusion, reject H0 is, we state that the two variables are independent. We reject H0. Therefore, we move to the H1. Therefore, answer conclusion with 5% level of significance, we can conclude that the opinion depends on the gender of the person. In that way you can make the conclusion. Now see the first exercise given in your course manual, page number 85. Let's read this one. The publisher is interested in determining which of 3 book covers is most attractive. It interviews 400 people. That means sample size is 400. It interviews 400 people, not the sample size. It interviews 400 people in each of 3 districts. Then the sample size is equal to 400 into 3. and ask each person which of the covers he or she prefers. The number of preferring each cover is as follows. Here given the observed frequencies, and the question here asks, do the data indicate that there are regional differences in people's preferences concerning these covers? And say use the alpha, that means level of significance 0.05. Let's see what are the two variables. One variable is region. Three regions concern here: Colombo, Badulla and Galle. And the other one preference, first cover, second cover and third cover. Preference of the book cover and the region. Here asked about this preferences depends on independent from the region or not. We need to check whether these two categories of these two variables are related or not. Then as a first step, state the null and alternative hypothesis. Always write the two variables are independent. There are no significant regional differences in people's preferences concerning book covers. H1 we can formulate as the two variables are dependent. That means the book cover, preference of book cover depends on the region. There are significant regional differences in people's preferences concerning book covers. Then as a step 2, we need to calculate the expected frequencies, and we need to find out the row column totals already given, but the columns totals are not given. But first you need to calculate the column totals, because when you are going to calculate the expected frequencies, always we need the row totals and the column totals. Here column totals are given, we need to calculate the row totals. This table we call as observed frequencies table. Then based on these observed frequencies, first calculate the expected frequencies for the corresponding cells. E11, that means this cell, this belongs to the first row and first column. Then take the product of first row total 323 into 400 divided by grand total 1200. That is equal 107.67. You can put E11 equal 107.67, and here see columns totals are remaining same. All columns total equal 400. Therefore, when you are going to calculate the expected frequencies belongs to the first row, all values remain same. Then applying the same procedure, you can calculate E12, E13. All values should be equal 107.67, but we need to satisfy the condition that the sum of these three should be equal 323. Therefore, just take one value as 107.66. Then this sum should be equal 323. Then find out the E21, that means this expected frequency belongs to second row and first column, this one. Then take the product of second row total and first column total, 266 into 400 divided by 1200. That is equal 88.67. All columns totals are remain same, therefore these values is same, but in order to satisfy the sum condition, as I mentioned earlier, the column totals and row totals should be same as given in the observed frequency. Therefore, just check second value as 88.66. Then find out the E3 one. Then take the product of third row total 611 into 400 divided by 1200, that is equal 203.67. In that way you can find out the expected frequencies. Once you find out the expected frequencies, then calculate the test statistic as a step 3. Then just find out observed frequencies and expected frequencies. Then first take the difference of corresponding observed frequency and expected frequency, square that difference and divide by expected frequency, corresponding expected frequency value. In that way you can get the sum, or you can calculate the chi-square calculated value. I'm not going to explain one by one. I think you have idea about this process, how to calculate the chi-square calculated value or test statistic value, and the here final answer is equal 129.537. In general, you can get an idea about if the chi-square calculated value is large, it's give an indication reject H0. But anyway, once you calculate the chi-square calculated value, as a next step, determine the critical value. Then you have to get the table value, then need to find out the degrees of freedom. In the example, alpha value exercise, alpha value is given 0.05. Then using this formula, find out the degrees of freedom, r minus 1 into c minus 1. Both variables contain 3 categories, then 3 minus 1 into 3 minus 1, 2 into 2, degrees of freedom equal 4. Therefore, we need to find the chi-square table value, chi-square degrees of freedom 4, alpha equals 0.05. And using the table, find here, now find the value, the degrees of freedom 4 and alpha equals 0.05, and this particular value is equal 9.4877. From the right hand side, in this table, in the right hand side, first find the degrees of freedom value in the last column, go down in the degrees of freedom column to 4, then move to left, then find the chi-square value corresponding to 0.05, that is equal 9.4877. Then compare to make a decision. Now compare chi-square calculated value with this table value. Decision rule: chi-square cal is greater than chi-square table, reject H0. Chi-square cal is a very large number, 129.537, table value 9.487. This is the critical value. Therefore, can clearly see chi-square cal is larger than the table value. That means this belongs to the rejection region. Therefore, our decision, reject H0. In the conclusion, with 5% level of significance, we can conclude that there is a significant regional differences in people's preferences concerning book covers. there is a dependency among the preference about the book cover and the region. Then see another exercise given in the course manual, that is given in page number 86, exercise number 3. Then see how do you perform this one. I think now you have a clear idea. First read this question and see what are the two qualitative variables. One is the level of management. 200 people selected at random from various levels of management were interviewed regarding their concern about environmental issues. Therefore, the second variable is environmental issues. There are 3 categories: no concern, some concern, and great concern. The response of each person was tailored into one of 3 categories: no concern, some concern, and great concern. The results are as below. That means here given the observed frequencies, and here given that the alpha is 0.01, under that level of significance, asked to check whether is there any significant differences among these 2 variables, level of management and environmental issues. Concern about environmental issues. That means the concern about environmental issues is depends on the level of management or not. In the previous one I forgot about how to check the conditions. That means if degrees of freedom is equal 4, that means just see the second condition that earlier we just discussed. Prior to apply the chi-square test of independence, we need to check the given sample is large or not based on the degrees of freedom. In the previous exercise, the degrees of freedom equal 4. Then the second condition given that if degrees of freedom lies in between 1 and 30, 80% of the cell numbers should be greater than or equal 5, and the remaining cell values should be greater than or equal to. Also we need to concern about that condition as well. As we done earlier, first as a step 1, let's write down the hypothesis. Always for the chi-square test of independence, the 2 variables are independent. It means concern about environmental issues is independent from the level of management. H1, concern about environmental issues, depends on the level of management. The 2 variables are dependent. In the second step, just calculate the expected frequencies. Initially, in the question, usually observed frequency table is given. First calculate the corresponding row totals and column totals, and see the categories of 2 variables. The concern about the environmental issues contains 3 categories: no concern, some concern, and great concern. The other variable, level of management, it has 1, 2, 3, 4 categories. Then find out the expected frequencies satisfying the given row total and column total remain same. Then E11, that is belongs to the first row and first column. Just multiply first row total and first column total, 40 into 70, then divide it by total number of observation, 200, that is equal 14. Then find E12, then take the product of, using these numbers you can find out the corresponding row and column. First row total into second column, 40 into 60 divided by 200, 12. Then E13, it indicates we need to get the product of first row and third column. 40 into 70 divided by 200, that is equal 14. Likewise, calculate the expected frequencies belongs to the second row, E21. Then take the product of second row total and first column total. 60 into 70 divided by 200, that is equal 21. E22, then get the product of second row total and second column. 60 into 60 divided by 200, that is equal 18. E23, second row total into third column. 60 into 70 divided by 200, that is equal 21. Then find the expected frequencies belongs to the third row, E31, E32, E33, E31. Take the product of third row and first column. 20 into 70 over 200, 7. E32, third row total. 20 into 60 divided by 200, that is equal 6. E33, 20 into 70 over 200, 7. Then find the expected frequencies of the last row. 80 into 70 over 200. E42, fourth row total into second column. 60 divided by 200, 24. E43, fourth row total 80 into third column. 70 divided by 200, 28. Once you calculate the expected frequencies, then find the test statistic value based on the concerning the observed frequencies and corresponding expected frequencies. And for performing this process, you can find the chi-square calculated value, that is equal 1.55. Once you calculate the expected frequencies, now here see all values are greater than 5. You have to check the conditions. Once you find the degrees of freedom, here degrees of freedom equals 6. That means the degrees of freedom lies in between 1 and 30. Therefore, the condition 80% of the cell. Then see how many cells are in that example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 80% of the cells, multiply 12 by 0.8, 9.6, that means almost 10. For the 10 cells, expected frequency should be greater than 5. When we move to the condition, now see the condition for the large sample. Now we need to consider about the second condition, because our degrees of freedom equal 6. Then we need to check these conditions. 80% of cells, in our example 12 cells into 0.8, 9.6, that means for the 10, almost 10 cells, the expected frequency should be greater than or equal 5. For the remaining 2 cells, the expected frequency should be equal or greater than 2. you can clearly see the condition is satisfied because almost all the cells, expected values of all the cells greater than or equal 5. Therefore, not need to worry about that large sample condition. We can proceed with the test. Then determine the critical value. Degrees of freedom equals 6, alpha equals 0.01. We need to read this value from the table. Alpha value 0.01, degrees of freedom 6, therefore corresponding value equal 16.812. Then compare two values, calculated value with the table value. Our calculated value equal 1.55, table value equal 16.812. Then in this example we can see chi-square cal is less than table value. Therefore this value belongs to the non-rejection region. Therefore our decision, no evidence to reject H0, do not reject H0. Therefore conclusion, with 1% level of significance we can conclude that there is no significant difference in the responses with respect to the level of management. In that way you can apply the chi-square test to check whether is there any relationship between two qualitative variables. In this lesson we discuss properties of the chi-square distribution. It is a positively skewed distribution. If degrees of freedom is increases, the distribution approaches to symmetrical distribution. Then we discuss about mean by chi-square test of independence. Using this one we check whether the two qualitative variables are independent or not. Then later we discuss few application of the chi-square test. In the next session we will be learn about how to determine the relationship between two quantitative variables, that is we call as a correlation. Using the correlation, the last chapter, the correlation analysis and regression analysis. In the correlation analysis, applying the Pearson correlation, we can test the relationship between two quantitative variables. In this lesson we discuss about how to check the dependent or independent, that means relationship between two qualitative variables. Thank you.